Hello friends, this is Rashmi Singh. Welcome to my channel Unraveling Science. Solutions for Magnetic Effect of Electric Current, Class 10, Chapter 12, Part 2. Back exercises. Which of the following correctly describes the magnetic field near a long straight wire? A. The field consists of straight lines perpendicular to the wire. B. The field consists of straight lines parallel to the wire. C. The field consists of radial lines originating from the wire. Or D. The field consists of concentric circles centered on the wire. The correct option is option number D. The field consists of concentric circles centered on the wire. The phenomena of electromagnetic induction is A. The process of charging a body. B. The process of generating a magnetic field due to the current passing through the coil. C. Producing induced current in the coil due to relative motion between magnet and the coil. And D. The process of rotating a coil of an electric motor. Correct option is C. Producing induced current in the coil. Third, the device used for producing electric current is called a generator, B. galvanometer, C. ammeter, or D. motor. Correct answer is A. generator. Fourth, the essential difference between AC generator and DC generator is that A. AC generator has an electromagnet while DC generator has a permanent magnet. B. DC generator will generate a higher voltage. C. AC generator will generate a higher voltage. D. AC generator has a slip ring while DC generator has a commutator. Correct answer is D. AC generator has slip ring and DC commutator. Fifth, at the time of short circuit, the current in the circuit A reduces substantially, B does not change, C increases heavily, or D vary continuously. The correct option is C increases heavily. Now state whether the following statements are true or false. A. Electric motor converts mechanical energy into electrical energy. The statement is false because electric motor converts electrical energy into mechanical energy. B. An electric generator works on the principle of electromagnetic induction. Statement is true. C. The field at the center of the long circular coil carrying current will be parallel straight line. Statement is true. D. A wire with the green insulation is usually the live wire of an electric supply. Statement is false. Live wire has a red insulation cover whereas the earth wire has a green insulation color in the domestic circuits. Seventh, list three sources of magnetic field. The three sources of magnetic fields are A. Current carrying conductor, B. Permanent magnets, and third is electromagnets. Eighth, how does a solenoid behave like a magnet? Can you determine north and south poles of the current carrying solenoid with the help of bar magnet? Explain. A solenoid is a long coil of circular loops of insulated copper wire. As you can see in the picture, the magnetic field produced around the solenoid when the current is passed through it is similar to the magnetic field produced around a bar magnet. To determine the north and south poles of the solenoid, we bring the north pole of the bar magnet near one end of the solenoid. If there is attraction, then the end of the solenoid has south polarity and the other has north polarity. If there is repulsion, then this end has north polarity and other has south polarity. When is the force experienced by a current carrying conductor placed in a magnetic field largest? The force experienced by a current carrying conductor is maximum when the direction of current is perpendicular to the direction of magnetic field. Imagine that you are sitting in a chamber with your back to one wall. Electron beam is moving horizontally from back wall towards the front wall, is deflected by a strong magnetic field to your right side. What is the direction of magnetic field? The direction of magnetic field will be perpendicular to the direction of current and the direction of deflection, that is either upwards or downwards. The direction of current is from front wall to back wall because negatively charged electrons move from back wall to the front wall. The direction of magnetic force is rightwards. Thus, by using Fleming's left-hand rule, it can be concluded that the direction of magnetic field inside the chamber is downwards. Draw a label diagram of an electric motor. Explain its principle and working. What is the function of split rings in an electric motor? Electric motor is a device that converts electrical energy into mechanical energy. Principle is, it works on the principle of magnetic effect of current. A current carrying coil rotates in the magnetic field. Working, when the current is allowed to flow through the coil M and ST by closing the switch, the coil starts rotating anticlockwise. As you can see here in the picture, this happens because a downward force acts on the length Mn and at the same time an upward force acts on the length St. As a result, the coil rotates anticlockwise. Current in the length Mn flows from M to N and the magnetic field acts from left to right, normal to the length of Mn. Therefore, according to Fleming's left-hand rule, a downward force acts on the length Mn. Similarly, current in the length St flows from S to T and the magnetic field acts from left to right, normal to the flow of current. Therefore, an upward force acts on the length St. These two forces causes the coil to rotate anticlockwise. After half rotation, the position of M and St interchange. The half ring B comes in contact with brush A and half ring C comes in contact with brush B. Hence, the direction of the current in the coil M and St gets reversed. The current flows through the coil in the direction T, S and M. The reversal of current through the coil M and St repeats after each half rotation. As a result, coil rotates unidirectional. The split rings helps to reverse the direction of the current in the circuit. These are also called commutators. Name some devices in which electric motors are used. Devices in which electric motors are used are electric fans, water pump, mixer and washing machines. A coil of insulated copper wire is connected to galvanometer. What will happen if the bar magnet is first pushed into the coil? When the bar magnet is pushed into the coil, a current is induced in the coil. As a result, galvanometer deflects in a particular direction. Second, withdrawn from inside the coil. When the bar magnet is withdrawn from inside the coil, a current is induced momentarily but in the opposite direction and galvanometer deflects in the opposite direction. Third, when held stationary inside the coil. When the bar magnet is held stationary inside the coil, no current will be induced. As a result, there will be no deflection in galvanometer. Two circular coils A and B are placed close to each other. If current in the coil A is changed, will some current be induced in coil B? Give reasons. When the current in coil A changes, the magnetic field associated with it also changes. As a result, magnetic field around coil B undergoes change and the change in the magnetic field of coil B induces a current in it. State the rules to determine the direction of a magnetic field produced around a straight conductor carrying current. Answer is Maxwell's right-hand thumb rule. Second, force experienced by a current carrying straight conductor. placed in the magnetic field which is perpendicular to it? Answer is Fleming's left hand rule. Third, current induced in a coil due to its rotation in the magnetic field. Answer is Fleming's right hand rule. Explain the underlying principle and working of electric generator by drawing a label diagram. What is the function of the brushes? The electric generator converts mechanical energy into electrical energy. Principle is an electric generator works on the principle of electromagnetic induction, according to which whenever a coil is rotated between the poles of magnet, an induced current is set up in the coil whose direction is given by Fleming's right hand rule. Working. As shown in the diagram, brushes B1 and B2 are kept pressed separately on the rings R1 and R2 respectively. Let the axle attached to the rings rotated such that arm AB of the coil moves up and arm CD moves down in the magnetic field. Due to the rotation of the arms AB and CD, induced current are set up in them. As per Fleming's right hand rule, induced current in these arms are along the direction of AB and CD. Thus, an induced current flows along ABCD and the current in the external circuit flows from B2 to B1. After half a rotation, the arm AB starts moving down and the arm CD upwards. Therefore, direction of induced current in the arm changes. Thus, net induced current now becomes in the direction DCBA. In the external circuit, now the current flows from B1 to B2. Thus, after every half rotation, the current changes its direction and alternating current is obtained from the generator. Function of brushes. Brushes are in contact with the two slip rings that helps in transferring current from coil ABCD to external circuit. When does an electric short circuit occurs? Electric short circuit can occur first when too many appliances are connected to a single socket or when high power rating appliances are connected to light circuits. The resistance of the circuits become low. As a result, the current flowing through the circuit becomes very high. This condition results in short circuit. Second, when live wires whose insulation has worn off comes in contact with each other, the current flowing in the circuit increases abruptly, which results in short circuit. What is the function of an earth wire? Why is it necessary to earth metallic appliances? The metallic body of electric appliances is earthed by the means of earth wire. Any leakage of electric current is transferred to the ground. This prevents any electric shock to the user, and this is why earthing of electric appliances is necessary. Thanks for watching. Please do like, share and subscribe.